Could you please repeat once again all these steps?
No, not all the steps.
No. For me, please, all the steps.
Okay. I will do that.
No. Мне только вот эту вот часть.
Вот, смотри.
Okay. Here.
First, why do we do this?
Why do you do this?
Yes.
Let's go back. Let's go back here. So, I would write it, draw it. You get your wells with a porosity log.
Yes.
You know how to obtain porosity log? You've done that in our previous classes. And you get a cell, a grid. Something like that. Okay? So first you've done upscaling. So you set a numbers onto these cells. And you obtain something like 20, 10, 18, 25, 15, 5, 20. That doesn't matter the actual numbers. Just you've done upscaling. And now for this cell, for these cells, you know the values. And now the problem arises that you need values here, in between. How to obtain values here? Do interpolation. And you're the one to choose the method of interpolation and the settings for that method, properties. What we are doing, we are coming to Petrel, and that's the process, petrophysical modeling, that's the process of constructing this porosity model. And Petrel is asking you about the method. So we are choosing, actually in the very beginning, we're going to choose Kriging. Okay, just choose Kriging. And to do Kriging, we know how it works on a 2D scale. We have to have radiuses right now in 3 directions. And we have to know time for the variogram. And we have to know Lagrange. How to obtain these parameters for your interpolation? We are going to the data analysis. And here to the variograms. So that is the place where you have to find type of the variogram, Nair effect, and the radius. That is the answer for question why. Now I'm answering the question how. You have to choose the parameters like the size of your step, the amount of your steps, and these parameters give you experimental variogram. So you're not counting it by yourself, Petrel is automatically calculated. Just you have to set a good parameters to make a good experimental variogram. And then you have to fit your theoretical variogram with this experimental. Is that clear?
Yes.
We are doing it something like that. That is in vertical direction. But still we have to do that in x and y direction, in horizontal directions. And that is the major and the minor directions. If we come to the major direction, you're choosing the azimuth, that means where these directions should look like. And then you're choosing, once again, number of flags and lag distance. So the size of your step and the amount of the steps. And simultaneously you're choosing the bandwidth, the tolerance angle, and the lag tolerance. So that is, it shows you this tolerance, this angle. The bigger this angle, the less you're following the direction, but more points. Okay?
Yes. What about bandwidth?
Bandwidth,
Yes.
you see, wait a second. Yeah, like that. That's the tolerance angle.
Yes.
But once it's reached bandwidth, it is not expanding anymore. You see? Bandwidth is this parameter. So if I'm doing it like that, my bandwidth actually is more or less equal to the search radius. So it's this direction is equal to that direction. And this is isotropic case. Okay? And your task was to find such a parameters of this search radius to make your variogram looks okay. Was you able to find these parameters?
Yeah.
Yeah? Okay. Just name it. What's the azimuth?
5.
5, okay. Number of flags?
20.
Okay. Lag distance?
20. 25.
50. How much?
235.
235. Okay. And you got different parameters, yes? Okay, we'll check. Okay, that's your parameters, guys. Yes?
We had another, but didn't say.
Oh, that's do you have it for both zones simultaneously?
It was for second zone, for first zone.
No, it's I got the second zone. Okay, and what's the type of the variogram that you choose? Gaussian. And what's the radius? Radius is here. It's a major range.
Average major range it is 736.
140. Well, it could be. Okay. Any other parameters? So anyone else get different parameters? Just to see.
60.
Minor azimuth?
60.
Okay.
Zero. After that, 20.
20. And line distance?
250.
Okay. And what's the major range?
1230. Point 554.
Okay, something like that. Okay? Well, I would not say it's very good, but yeah, it's a kind of.
But here I don't have it.
I used, by the way, like variogram map, and there were like azimuth around 500 or 5 grads,
5 degrees.
5 degrees after a day.
Okay, yes, it's a way of obtaining the data. And the thing I want to, like, the practical advice once you're working with the variograms. Usually, it is very hard to set a good variogram, like in practice. So, and you don't have too much time spending on these diagrams. So what you're gonna do? First of all, the same constraints as we used once we've done the diagrams for the well tops. What's the smallest radius that you can use? Distance between the wells, the smallest distance between the wells. Yes, in vertical it's 1 meter, but in horizontal it's depending on the distance between your wells. And then sometimes it happens that you can find a kind of a good realization of one variogram, but simultaneously you get a tremendously bad variogram in perpendicular direction. What you can do? In this case, you can say that your data is isotropic. And you simply use the same radius for both directions. It is possible to do that. And in the report, you have to write that. Yes, we've done variogram analysis. We find that in this direction, the variogram is looking more or less good. And the radius of the variogram is like that. And on the opposite direction, on the perpendicular direction, it is not looking pretty well. So we've been choosing the same radius. Okay? Mm-hmm. Now let's assume that we've done these variograms well. Okay? Press OK here. And in this window, we have to check this button. Use variograms for data analysis. And simultaneously, you have to choose to use transformations. Okay? So once you press it, you're unable to change the data here. But it is set as we set it. So 5 meters vertical, 1,025 dozens in major and minor. And the time is Gaussian in my case. Okay? Now let me go to the 3D window.
What if we have nothing in total still and the range is just blank?
Here,
Yeah.
something is wrong.
Yeah, we know that.
I will come and check. First, let's do for those who is ready. You are choosing create, and let's press apply. That's the situation that I got. Okay? Do you have something to say?
No, we didn't get anything because we don't have even like numbers on Nugget.
Why it's not HD?
Okay, I will come and check.
We don't have anything here. Maybe it's
Because you use issues. Yes, because in your case, you did not create a separate variograms for a separate faces. You see? And in this case, once it's not set, control is telling you you did not set it. Okay? Okay, let's choose Kriging. And we've done that for the second zone only. That's your result.
Why can I change the numbers of the range?
Because you did not press this button.
Okay, thank you.
It's according to your data.
Sorry, sir.
Aerodrome.
Что это у нас получилось? Что надо включить на 3D окне? КПУ? Вроде не могу найти КПУ. О боже, что это за Что это за
Okay, do everyone obtain the porosity Q?
Yes, but I have 30% of high is high porosity and 30% zero.
Well, it depends on the distribution in your data. So come on guys, let's look at the result, which is shown here. I'm going to ask you a couple of questions, and you're going to be able to answer correctly. What's the algorithm did we use here? Kriging. How do you think? What's the values here? Average. How do you think? What's the distance here? Radius. You see how it's working. You know how it's working. And why you have this radius? Because we got it in the data analysis. And why we got it in the data analysis? Why you got these radius in your data analysis?
Because we have to interpret it.
Because you're the one, because you set the settings to obtain this experimental variogram, and you're the one to set the radius of theoretical variogram. So in the end of the day, you're in charge. Okay? And let's make a couple of funny calculations. What's going to happen if I use these parameters? How my map going to look like? How my cube, actually, it's a cube with these parameters.
The side rotation.
Ребята, тоже, пожалуйста, смотрите, что ты построила. Да, я знаю, как это делать.
Okay. So what's going to happen?
A lot of points.
Hmm?
A lot of points like blue eyes.
Yeah. Like that. You see? Okay. What's going to happen here? How the map gonna looks like?
DK versus one side.
All lines.
Yes. What's going to happen now?
Average.
Average. You see, you know how it is working. It's actually not quite you can feel it. You can predict. And that's the best thing actually in life, when you can predict what's going to happen. It's like be able to travel back in time. So you know what's going to happen. Was just the distance. Okay. What if
when you change this to 2000, how do you know this is average? When you change this parameter,
this one
there is, yes,
for, let's say,
2000 and this is 200, yes.
this area is average.
How I know this?
Because it is, the size of the cell in our case is 50 meters. So 4 cells and we reach the radius, because the radius is 200. And out of the radius, in case of the kriging, we got average. Okay, and the same story. If you get nugget equals to 1, that means the accuracy of your data is very bad, and kriging simply gives you average all the way. Okay. Ready for the next step? Now let's choose Gaussian random function simulation. The result is gonna be different. So just let me show you. You see? This result is more or less the same as the previous in the area where you got a lot of wells. But it's quite different in areas away from the wells.
Нет, у меня сколько есть? Нет? У меня подписано было.
Okay. And now it's a bit more complicated because you never work with this algorithm. What's going to happen with these parameters?
A lot of different colors.
Yes.
Wow.
Because right now, in a distance of 200 meters, it can change completely. And it can obtain the random values. But as we know how the algorithm is working, so it's randomly, for example, in the first run, gives to that point and then gives a high value here. So right now, near this point, you're going to have an increased value of porosity. And in this point, you got small value, and you got a decreased value of porosity here. That's how it works. And once you're increasing radius, like it's 200, let's make it 500. The size of these objects just increased. Because the influence of each point is increasing. You see that? As we've done in Kriging, as we've done in previous assignments, the higher the radius, the higher the influence of each point. Okay, difficult question. What's going to happen now?
Average.
It's not Kriging.
Just gain a lot of different colors.
It's going to show you noise. Because what do we say? We say that our initial data can get any value in any distance. And it's just randomly set the points in our area. And by the way, funny thing, if you do radius like that, what's going to happen? The same result. But why?
You know, our data in very small radius.
Yes.
The one is
Yes, and we know that once it reaches the 50 meters, it can obtain any type of values. That's what is happening. Is that clear?
More or less.
More or less. Great. I'm going to give you a task to like redo that in a smaller, on a smaller speed. Okay? But I see at least a couple of you do understand what I'm talking about. And it's very good, because you guys gonna tell that to other group. Okay, what else we can do? If we come to the distribution part, you can click on estimate, and it gives you the data range that is in your data inside. And you can easily, by yourself, change these numbers. So in our data, in my case, velocity is changing from almost 4 to almost 35. I can set it as I want. Okay? And okay, almost final thing till I leave you to do some practice. We've been talking a lot about this random Gaussian function, and I said to you that it is stochastic, yes? And once it's stochastic, it's gonna give you a bit different results on any run, okay? So, according to my words, if I press apply right now, it's gonna recalculate this stuff, and we're gonna obtain a bit different result. Let's try. It's not working. It's the same result. What's the problem? Did you ever work with the programming? no, you'll never work with the programming, at least deeply. Can modern computers generate random values? No. It's a funny mathematical thing, but computer is unable to do complete random values. It's only simply running a certain algorithm and running it with the same parameters. So if we go to the distribution part, and here's the seed number. This number actually, I cannot tell you exactly what the number itself means, like it's 16,321, but it shows the way of calculating. So it's not quite random. It depends on this value. And if I change the value, like that, and press apply, it's gonna give me a different result. But till this box is clicked, all the next calculations gonna be done in completely same manner. And that actually is a bit useful. For example, once you do the calculations on your computer, and you want to repeat these calculations on another computer with the same data set, you simply need this number. You type it and you obtain the same result. So it's like random, but not quite random. But still, once it's stochastic algorithm, we're going to be able to obtain more than one realization, more than one porosity. Let's obtain more than one. Click on common. And here we got number of realizations. I got 5. Okay, let it be 5. You got, well, make it 5. Because 5 is better than 2. In case of the grade. And press apply. And you see in your model tab, right now you got 5 different realizations.
That's good.
And if you look at them, they all are done on the same data set with the same parameters, but they all are a bit different. And the main difference actually is located in the area without wells. Okay? Why? Because it's like randomly set in the area. But depending on the parameters that you put here. What's going to happen if you take lots of realizations and then calculate the average? What's going to be the result? It's going to be the result equal to creating. Okay? Well, 10 is not enough to obtain that situation, but if you make like 1,000, it's going to show you. But it's just a wasting of time. So in practice, once you're going to work with number of realizations, keep in mind that the more realizations do not mean the better result. So if you make 1,000 realizations, take the average, it's going to give you simply creating. Okay? Is that clear? Okay. I suppose that we've done here. Any questions? Geostatistics is not as easy as geological modeling, but still it is able to be understood. I will send a guidebook on geostatistics practice for your attention. So you have to do that step by step in your free time. But I hope that after today's classes, you're going to have a bit more understanding of what is happening. Okay? The general idea is simply how to find the variogram radius.
And these geostatistics practice tasks are related to our geological modeling.
Yes. The important thing that once you're doing your geological modeling assignment, now after these classes, you don't have to set simply 5,000 meters as the radius once you do interpolation. You have to go and create a good variogram. And once you're going to defend the work to me, you're going to explain why you set this radius, how you set this radius. Yes?
We will try anyway.
You still have a chance to take off your documents from the data. Or at least you can try to understand just statistics. Okay? That's
Have
it
you
for
got the
today.
videos on YouTube?
Not yet. Not yet.